Alright, welcome to our next video here. We're going to look at the next bunch of quadrilaterals. We're going to look at rectangles, rhombus, square, and trapezoid. First thing is rectangle here, and I want you to notice what I have here on the left side. If you look at those properties, those should look familiar. Those are actually the 5 properties of the parallelogram. I want you to take a quick second and think, do these properties apply to this rectangle? Draw some diagonals in here. You should actually, all these properties absolutely do apply to this rectangle. So as you can see, I only have 3 properties listed here. So the question is, how do I get all of these properties to fit right in here? And since they're all properties of a parallelogram, we're simply going to write that a rectangle has all properties of a parallelogram. So that one statement covers all those 5 properties. Now, obviously, there are some extra properties, too, that are unique to a rectangle. One, we should all know that a rectangle has 4 right angles. That's unique, different from a parallelogram. So we will say 4 right angles. The other property has to do with the diagonals. In a parallelogram, we do know that the diagonals bisect each other, but the parallelogram, the diagonals were not congruent. In the rectangle, not only do they bisect each other, but they are congruent in length as well. So we're going to say that the diagonals are congruent. Alright, next up we're going to take a look at the rhombus. Okay, in the rhombus here, we take a look on the left side, and again I have those same 5 properties, the properties from the parallelogram, and every single one of them applies to this rhombus. We have opposite sides parallel, we have adjacent angles supplementary, so all those properties apply to this rhombus. So we're going to write, just like we did with the rectangle, that a rhombus has all properties of a parallelogram. Now there are 3 more properties that make a rhombus unique and different from a parallelogram. We can see it looks like a parallelogram, but there are a few things that are going on here that make it unique. The first and most obvious property is that, unlike a parallelogram, in a rhombus all sides are equal. Very important property, will help us solve a lot of problems. Alright, the other 2 properties, or the last 2 properties, have to do with the diagonals of a rhombus. So I'll draw them in blue right here. Those diagonals, a couple things going on with them. First, the diagonals themselves are perpendicular to each other. Again, very unique, different from a rectangle, different from a parallelogram. So we're going to say that the diagonals are perpendicular, meaning they're forming right angles in there. The other property is what goes on at these angles. These angles, get this in a different color, these angles over here, these opposite angles, are actually getting bisected by the diagonals. Alright? And these are getting bisected as well. So that's definitely something different from a rectangle and a parallelogram, is that the diagonals bisect the opposite angles. Alright, we're going to check out a couple problems with rectangles and rhombus in our next slide. Alright, in this first problem we have a rhombus, and we're given an expression for MH and HT. We are asked to find MA. Okay, the first thing we need to do is get a relationship between the sides. We just talked about a rhombus. We talked about all sides being equal. So it's as simple as saying y plus 8 is equal to 4y minus 7. If we do a little math, we would get y equal to 5. Now we're looking for MA. So you might say, well, there's no expression on MA, but since all sides are equal, we know that MA will be the same as MH or HT. So all we have to do is take this 5, plug it in to y plus 8. So this would be 5 plus 8, which would give us a length of 13. So MA, just like all the other sides, are length 13. In this next problem, we're looking at a rhombus. It doesn't give us a picture, so naturally we're going to draw one, and we're going to get our diagonals in. Now, there's a lot. The only thing they tell me is that the diagonals are length of 10 and 24, and our job is to find perimeter. Now, the only way we're going to find perimeter is if we find the value of the length of this side. If we find the value of length of that side, we'll know all the other sides, and we'll be able to find the perimeter. Well, let's take out what they gave us. The first diagonal, you can see that they're two different lengths, not equal. First diagonal is the shorter one. We'll call this one the shorter one. This will be 10. Now, we do know that the diagonals bisect each other, so that means that I can break that 10 up into a 5 and 5. Now, the longer diagonal, which I'll label here in blue, that they said was a length of 24. I'm going to break that up into 12 and 12. Now I did that because what the diagonals do is they form this little triangle right here. But one of the properties of a rhombus was that the diagonals were perpendicular. So we were able to say that this is a right angle because they're perpendicular. What that forms is a right triangle. Now I have a right triangle down here in green with two sides known and a missing side. This allows me to use Pythagorean theorem. 5 squared plus 12 squared equals x squared. I'll get x squared is equal to 169, and I'll get x to be 13. That means each side is 13 units long. The perimeter would be 4 times 13, or 52. All right. So just think about the properties we used here for these two problems. In number 1, we used the property of all sides equal to help us get a value of y. And in number 2, we used a bunch of properties. We used diagonals perpendicular to each other, we used diagonals bisecting each other, and we used the fact that all sides of a rhombus are congruent. It's important to be able to associate the property that you're using when solving a problem. For this slide, we're just going to do question number 3. It's a pretty simple rectangle question. Again, no picture, so we're going to draw it. And we got rectangle ABCD. They give us a length of AC, which is that diagonal, and a length of BD, and they ask us to find the length AC. Well, what's the relationship between AC and BD? Well, they're both diagonals, and we talked earlier that the diagonals in a rectangle are congruent. So again, it's as simple as saying 3x plus 15 is equal to 4x minus 5. The algebra here, if we get x by itself, will get us x equal to 20. And we're looking for AC. So if we plug in 3 times 20 plus 15, that will give us a value of 75. And again, what property did we use? The fact that the diagonals are congruent. Alright, the next shape we got here is a square, and if you'll notice all the different properties that I posted up here on the left and the right, if you notice the ones over here on the left, those are properties of the 5 properties of a parallelogram. The ones over here in blue, those are the properties, the extra properties of a rectangle, and the ones in red here are the properties of a rhombus. Of all those 10 properties, the square has every single one of them. Every single one of these properties listed is true for this square. So, if a square has so many properties, how come I've only given 2 spots for properties? Well, what we're going to do is, just to sum it up, we're going to say that the square has all properties of a rectangle, which it does, and we're going to say it has all properties of a rhombus. Now you may be saying, well, what about the properties of the parallelogram? Well, if you remember, when we wrote down the properties of a rectangle and rhombus, we included those properties as well. So when I say it has the properties of a rectangle, I'm including the parallelogram. Same with the rhombus. All right. So by just saying these 2 statements right here, I'm basically encompassing every single one of these properties for this square. A lot of stuff going on in the square as far as properties. All right. I'm actually going to leave the trapezoid slide for class. Something very important going on with trapezoids here, so I'm actually going to save this for class, and we'll fill this out then. And so that's the video. Hope you enjoyed, and we'll see you in class.